Hi, welcome back to the breadboard. It is Thursday, the 3rd of June, which makes it the 5th day of our Texas Instruments IoT week. And today we're going to add Wi-Fi capability, make our CC3200 a true participant in Internet of Things by having it send out data to the cloud and also subscribe to data from the cloud. We're also going to have a quick upgrade to the display where we're going to take it from what you can see right now, and this is what we're going to take it to. As you can see, a much prettier display, more useful, other useful information on it. So when we left off at the end of yesterday's session, day 4, we had the temperature sensor, the TMP275, reading the temperature, putting it on the display, and also sending it out onto the serial port. If I just enable the console, you'll see it outputting it right there. Okay. We also had it turning a fan on and off. So if I heat up the temperature sensor right now, this is actually live, and take it over 27, which was the threshold. All right, it just said on there, and then when it goes lower again, it'll just say off. But really, it's not a very good display or very friendly, so we're going to improve upon that as well. So what do we need to make all of this happen? The first thing we need to do is get internet connectivity up and running. We're going to use MQTT. It is a well-known messaging protocol based on a publish and subscribe paradigm, where the sensor publishes to the cloud servers to let any subscribers be able to grab that data. Now, there's a complete disconnect between who a publisher is and who a subscriber is. They don't need to know who each other, but the MQTT server in the middle acts as the gateway between the two of them and the intermediator. So the publisher simply publishes the data up. It tells it that it has a topic, which is really a description of what that data is. So it would be temperature, fan status, time, stuff like that. And it would then send a value along with that. A subscriber would go to the same server and say, hey, I'm interested in temperature, or I'm interested in time, or I want to know what the status of the fan is. And anytime those things changed, the MQTT server would publish the data out to those subscribers so that they can get the updates. But the key thing here is that the publisher and the subscriber are not even necessarily aware of each other. They simply communicate via this MQTT server in the middle that's up in the cloud somewhere. And you can have multiple subscribers to the one publication as well. It doesn't matter. Quite happy to do that. The libraries are already built into Energia, as well as the Wi-Fi libraries for the CC3200, and there is a demonstration already available for the Wi-Fi. If you go into I've just got day 4 loaded right now. If you just go into the sketch, the examples, and go down, you've got some Wi-Fi samples already here. Now, if you go in and you make sure you've got your board set to the board you're using, so in my case, it's the CC3200 EMT Launchpad, and the serial port set up. When you go to the examples, then in Energia, there's a lot of folders where these examples have been tweaked specifically for the hardware that you're trying to program to. So if there are some nuances between, say, an MSP430 G5523 or a CC3200, there will be a separately coded example in a folder relevant to that hardware. And in this case, we're using the CC3200. So when we go in here and we look at the Wi-Fi, we know that these are going to work with the CC3200. Now, because we know we're going to use MQTT as well, we're just going to go straight to the MQTT folder and pull in a demo here. Now, I'm not going to run these demos, but I just want to quickly show you. It pulls in the libraries relevant. You can see here this is actually written by IBM, because IBM are the company that is actually pushing MQTT. We're going to use Eclipse, which is also very well known in the Internet of Things community, and it's their MQTT server out in the cloud that we're going to use. We have libraries that we need to include, which is a Wi-Fi stack, the MQTT client stack, and Countdown. So these are all required for getting the product to work. To connect to your local Wi-Fi, of course, you're going to need to know what your SSID is, and only you're going to know what your local Wi-Fi settings are, and a password for that. We have some buffers, and then we have a set of functions for publishing data to the MQTT server and receiving it. Now, the MQTT simply needs to know that there's a TCP/IP stack underneath it. The fact that it's Wi-Fi, it really doesn't care. So, if you want to run this Wi-Fi sample, go ahead. I'm not going to run it here. I just wanted to show you that it does exist already for Energear for the CC3200. And what I'm going to do is I'm going to take the libraries that are being used here and base my code on parts of this and some of the other samples to create our own application that's going to be improving things. So let's open that now and we will have a look at what I've done. So we're going to Sketchbook. I've already written, tested, and saved this to save time with you guys. So here is our sketch. Okay, so here is the new sketch, which is an extension from the one we finished with yesterday. I will be providing all of these so that you can download them and use them yourselves and adapt them. So what we've added in here are the libraries for the Wi-Fi and MQTT, which is these few statements here. These ones above it were already there. We've included an I2A.H function because the CC3200 compiler stack does not include an integer to ASCII function for whatever reason. So they've just put a little function at the bottom of this script to be able to do that for us. We will be using it in a little bit of conversion to send things out to the MQTT server. The TMP275 was already there, so I'm not going to describe that again. So the serial, so is this, so is this. So you need to put in your own SSID and password for your network. So these are all new. This is all new for the Wi-Fi, and then for MQTT, there's a bunch of variables here. These ones are just buffers for sending and receiving data and manipulating it before we send it out. You've got the host name, which is the name of the destination MQTT server that we're going to be using. And we've got the port. This is the standard port for MQTT, which is 1883. These two timers variables here are the same functionally as what we've been using for all the other routines. So I'm not going to go into a description, but we're just adding two more so that we can schedule the publications of the MQTT data. We then have some more constants, and these are for the different topics that we're going to be subscribing and publishing to. So we've got two subscription topics, which is the breadboard set high and set low. These are for the temperature comparison. So if the temperature goes above set high, it will turn the fan on. If the temperature goes below set low, it will turn it off. We then have three publication constant topics, where one is temperature, one is the fan state, and one is the time. So we're going to be this is data that we're going to be sending out versus pulling in. So that's all there is for the variables. Now we come to the setup routine. The ones that are already here, I'm not going to go over. The new one we've added is setup Wi-Fi. So following the same structure as before, we've got an init Wi-Fi, which sets up and connects to the Wi-Fi network. And then we have a connect MQTT, which once we've got the Wi-Fi connected or a TCP/IP connection, whether it be Ethernet or wireless, doesn't matter, we will then connect to the MQTT server, which is the Eclipse servers. And that's the only two functions that we've added to the setup. So the really nice thing here is it's very simple and very easy to comment things out if you don't want to use them. In the loop function, which is where we run around this very, very quickly, constantly, we've added one function, which is called update MQTT publications. So now we come to the new functions. So the first one we're going to look at is the init Wi-Fi, and then we'll go on and look at the MQTT ones. So let's just scroll down here a little bit. These are all the MQTT. So here's the Wi-Fi one. And what it's going to do is we're leveraging the serial console just so we can see a status of what is going on. It's going to tell us we're attempting to connect to the network. It's going to print out the SID that we're using. It's not going to print the password. It's then going to start the Wi-Fi stack, giving it the SSID and the password. And when it gets connected, it's going to tell us that it's actually connected. While it's waiting to connect, it's going to print out little dots. Once it's connected, then it's going to print out our IP address. So here's connecting, and then here's getting a local IP address. And then we're going to say, okay, well, here's our local IP, and it's going to return, and we're going to continue our program. And that's all it does. This is very, very standard stuff for Wi-Fi, and whether you're using a CC3100, a CC3200, or some other Wi-Fi adapter, maybe a WizNet, 5100 board or something, they're all going to follow a similar pattern. Okay, so I'm not going to go into any deeper than this. You can look that up yourself, or we'll be doing a topic on different Wi-Fi boards and maybe some separate videos. So let's go back now, and now let's look at the MQTT stuff. So now we've established the network connection. Now we're going to be connecting to MQTT. So that's the next function we're going to have a quick look at. So here is connect MQTT, and what this is doing, again, we're going to print some things out to the serial port so we know what's going on. So the first thing we're going to do is to say we're going to connect to whatever the host is, in our case it's Eclipse, and the port. We're going to print that out the serial port, and then we're going to send out a command to the IP stack to say connect, and we're giving it the host and the port number. This is a low-level connection. It's not necessarily talking at a higher level to MQTT yet. It's just connecting to the server. The next thing we're going to do is connect to the MQTT application above that on the remote server. So we're going to tell it who we are with a client string and a few other parameters, and we're going to send out the connect command. And once that's connected, it's going to come back and tell us we're connected. If we get an error, then we're going to publish that out. So if the return code from this connect is not 0, it's just going to give us this error, but it's still going to continue on. Really, this needs a little bit more work to make it more robust. Then what I now have after that, so now we've got connected to the MQTT server. Now we need to subscribe. This is where we say, I'm interested in something. Please send me it if you get anything for that something. So, and that something is called a topic. We're going to subscribe to two things. So we looked at the constants up the top. There is the temperature high and temperature low set points that we were interested in. So we send out a command which is client.subscribe. We give it the topic, and we give it the MQTT quality of service value, and we also tell it the function that should be called if a message arrives that is relevant to that topic. So we do that, and we remember if there's an error or not, and then we subscribe to the low topic. So this one was to the high set point topic, and this is to the low set point topic. And then if we get an error here, we remember that as well. And then if we get an error in the subscriptions, we'll print out the fact that we got an error. If we were successful, we'll just say successful, and we continue on. And that's all there is to subscribing at a high level to an MQTT topic. In fact, we're doing two topics here. Now, before we go back and look at the main routine, we're going to quickly look at message arrived high and message arrived low, because these are the two relevant to the subscription. So we've told it we're interested in knowing about this data. So what happens when data arrives? So there's two functions here. Let's go have a look at them. So here is message arrived high, and what comes in is an MQTT data structure, message data, and we convert this into something we can use. We're then looking, the bit we're interested in is the message payload. If you want to really get into this, there's lots of topics, and I'll provide some links in the descriptions to the mqtt.org website and everything else where you can read into this. And there's quite a few sites that have some great information all about MQTT. So anyway, our message arrived, we get it into the message, we get access to the message payload. We extract that and convert it to a string because this is a character array. And then I convert the ASCII to a float so that we can set it to our fan temperature double variable. So this is now overriding it. Now in a full production system, and where you would put a lot more error handling in here so that you can say if the temperature is, if the high temperature is less than the low temperature, ignore it, or adjust the low temperature maybe a few degrees below it or something like that. If the high temperature is set to say 1,000, ignore it. You would put in some error handling here. I haven't done that right now because I want to keep these simple so that they're easy to understand. And I don't want to complicate the routines with all the extra belts and braces that you would normally put in here for a production ready system. The message arrive low is pretty much exactly the same. The only real difference is it's updating a different variable, and this is the variable that controls when the fan turns off again. And everything else is pretty much the same. We also print the value out to the serial port just so that we know that it is has been received, even though we may not necessarily see it reacting right away anywhere else. And that's all there is for these two messages that arrive in. As you can see, at a higher level, that's pretty easy to set up and make work. we've now done the connect MQTT. So now what's going to happen is we're going to drop into the main loop, which is just going to loop through these. And as I said, the only thing we've added to here is the update MQTT publications. So we're going to be repeatedly calling this. All these other ones we've already talked about in the previous videos. And what's happening in here, you can see it's actually quite short. We have the standard little timer routine, which only allows us to go into this once every MQTT pub delay period has elapsed, which I think I've set to 10 seconds at the moment, because most of this stuff you don't really need to update it that often out into the cloud. So when we come in here, first thing we're going to do is we're going to do an F2A. That's that extra function that we had to add, which converts our current temperature into a string so we can send it out to MQTT server. And then we call publish to MQTT. We give it the topic, which is the topic published temperature. That's one of the constants we have up the top. And we give it the buffer that was returned from this F2A, because this takes a character array to be published, not a string or an integer or something like that. And then we do another sprint, which we convert the current milliseconds into a string and put it in the buffer. We then publish with a different topic. So this time it's publishing to time topic, the buffer. Then we take the fan state and we do the same thing. Now fan state is a Boolean, and I'm just converting it to a double so that it just shows a 1 or a 0. And then we publish that to the fan state topic. All right, and then we yield for 500 milliseconds, basically gives the subscriptions time to handle any data that might have come in. We reset our delay for another 10 seconds. So really this is going to be delaying like 10.5 seconds. And then we just return. And it's just going to keep looping through this and forever, as well as these other functions. Publish to MQTT function is right here. And that's the only thing we haven't looked at yet. And I've just separated this just because we call it 3 times. And as you add extra sensing data and extra things you may be interested in, you don't want to keep repeating this exact same code up here. So I've just pulled it out and put it into its own function. So this takes 2 parameters. We take the topic name and we take the buffer, which is the character buffer, basically the value. We check to see if we're still connected, and if we're not, we call connect MQTT again. So this is that bit where we called this once during setup, but sometimes you do get the MQTT connection drop. I mean, it's the internet after all, dropouts are inevitable. So it will reestablish the connection if it was lost. Once it's got that verified that the connection is established, it sets up the message. So there's a few things here which I'm not going to go into the details of. You've got quality of service. You've got whether the MQTT server remembers the value. If you set this to false, it means you send it, and if there's any subscribers interested, they will be notified. If you set this to true, the MQTT server will remember the value, and so any new subscribers after you publish this will also get this value. Message set to false so we don't handle duplicate messages. The payload is the buffer, and the payload length is just how long the buffer is. And then we simply call client.publish, and we return a return code value. 0 is success, anything else is a failure. Now right now I'm not handling the return code, because again that gets into the belts and braces, and I just want to keep this relatively straightforward so that you can get your own examples up and running, and then you can enhance that with the extra error handling and things that you need as time goes on. The other thing I wanted to quickly show you was for the display. So we've added some extra lines in here. So originally we just put the IoT week with a line underneath it. I've now actually put a box around the temperature setting. So there's an extra line, a few line loops here that just draws the box. I've also included the high and low set points on the screen and a fan status on or off. So I've added the word fan so we know what it's about, and defaulted it to off because that's how it powers up, and then this will just get turned on and off as necessary. And the update screen also now includes refreshing the fan temperature on and off values as well at the right locations. And that's pretty much it. That's really the only thing I did to this screen. And it's a much more improved screen value. So let's just go have a look at what happens when I upload this. So I've got my webcam currently looking at the screen. So this is where we left it yesterday. All right, we've got the IoT week with a single line. We've got the temperature, which is currently being set, and I can show you that changing. It is live. I've got my finger on it now. There we go. As it goes up above 28, you see the fan turned on. I don't have the fan physically connected right now because we showed you yesterday it working, so we know that works. And now it's off again because the temperature's dropped down below 27. But this is the old display. So let's upload this new code. You'll see this goes off. The reason the display goes off, by the way, is because the power for the display is from one of the GPIO pins, not from the 3.3 volt supply. And when you start uploading code to a CC3200, it resets the pins during the upload, so it effectively pulls the power from this. If I had left the power on, you would see the display would just sit here for ages before it slowly faded out. So that's the download complete now, and here's the new display. So it looks a lot nicer. We have our low and high set points. We've got the fan status. We've got our elapsed time ticking away here nicely. And we have our temperature. And if I put on the serial console, you'll see it's still sending out this data to the serial console, which is quite nice and handy. We've got our set points and our fan. So what else do we now have? Well, we have the MQTT working. So what I want to do is bring up an MQTT piece of software that will allow us to subscribe to the Eclipse server separately. I don't want to get into any fancy smart device displays in this video. We're going to do that one later in the week. But this one, we want to see what the data is on the MQTT server that's arriving there, and we want to be able to send a publication to it for the high and low set points to see if the CC3200 is going to receive this. So the application I'm using for this is called MQTT Lens. This is a Chrome add-on, so you can just go into the Chrome add-ons and you can just download it, and and you start it up through the Chrome app launcher. So the first thing you need to do is set up a connection. So we're going to use the Eclipse MQTT. This is, remember, this is the default because it's MQTT Lens. One of the most popular ones is Eclipse. So we're going to use the Eclipse MQTT server anyway, and the URL for that is iot.eclipse.org right here. So it's Eclipse and it's iot.eclipse.org. The client ID is just a GUID just a random ID that's been set up by this. You can put in one of your own if you like. Because we're using a public open MQTT server, just a random ID is fine. It just keeps it unique to yourself for the data. And we don't need credentials because we're not using a secure system. If you wanted, in a production system, if you didn't want to share the data, you would put in a username and password, and you would set up MQTT to use authentication as well. We're not going to do that right now. So here's our setup anyway for the connection. We just say create connection. And if it's going to work, it'll say connected, which this has. So the first thing we want to do is we want to subscribe to the temperature. So without getting in, again, a lot of detail, the subscription topics, you can actually set them up hierarchically. So all of mine are under the root topic of the breadboard, which is obviously my channel. And then I've got / and then fan state right now. So I'm just going to change that to temperature. And then that's all I need to add here. And if I hit subscribe, it's now going to go out to that MQTT server and subscribe to that data. What's going to happen is every 10 seconds, it's going to publish the new temperature, right? 34, 45, 24, 34, 44, 45. Because remember, it's 10 and a half seconds. So another 10 and a half seconds, you'll get another one. And if I put my finger on the temperature sensor, you'll see the next one that comes up. See what's happening here? It's coming up. And we'll see that anytime now, it should be over 30 degrees when it actually publishes next. And there it is, 30.12. This has started to drop now because I took my finger off. So there we can see that the CC3200 is indeed publishing quite happily out to the MQTT server. And let's just set up a couple of other subscriptions. I'm just going to minimize that. So we got temperature, we want the time, and we just say subscribe, and we'll see the time coming in the same way. And we want the fan state. So we'll subscribe to that. And there's the fan state. So let me just force the fan state on before we move on to publications so that you can see that that is going to be sent out. So fan is now on. And if I hold my finger on it to keep it up there, see there's now a 1 to say it was on. It was zeros before. Now it's a 1. Now if I let it cool down again, it should go back to a 0. And as soon as we've confirmed that, we will then move on to publications. See, it's still a 1 because the temperature is still high. It's got to go down below 27. The fan is still on according to here, and of course according to the publications it is still on as well. Any moment now it's going to come off. It's into the 27s. As soon as it goes below 27.0, it's going to go off. There, off. So the next one that comes in should say 0. There it is. So now we've confirmed that we are indeed happily sending our data out to the cloud. Yee! That's great stuff. So let's just minimize these. We've got 3 things that we are publishing to, subscribing to here on MQTT Lens, and we're publishing it from our CC3200. So now what if we publish something that's not directly connected to the CC3200? And what I've got is 2 properties. Remember when we did the subscriptions, there was the breadboard set high and the breadboard set low. This set high is setting this value here. So right now you can see it's setting 28. I'm going to send it a message that says set it to 33.0. And if I hit the publish here, so there's the topic and there's the value, and if I hit publish, any second now here it's going to show up. There it is. So it just took a second or so, but now and remember this display is only being updated once a second as well. So now there's the new value, and if I wanted to show you that it's taking notice of all of it, just go 33.12, and that will show up any second now with 33.12. There it is. So now if I start warming this up again, so is it really taking notice of this? In real time, remember it was 28 that was going on. It's no longer gone on at 28. It needs to get to 33 now. I don't know if my finger's going to warm it up that much. Yeah, it might. Almost there. There, now it's on. So there we go. We've sent from a completely separate system to an MQTT server. So this CC3200 does not know about MQTT Lens that's publishing data up to the MQTT server on the Eclipse site. But it does receive the information that was sent there, and it does indeed update its operation based on that. So now let's do the same thing with the set low value, and we'll send it 10.00, and we'll just publish that, and this should adjust this one here. And there it is, 10.00. We'll go back to the high. So I can't get that cold, but let's just set this to say 30 degrees instead. I'm being careful of the values I put into this message because, as I said before, I don't have any error handling to make sure I have the right length of characters, to make sure it's a proper double value that's coming in, and things like that. So I can, right now, it would mess up if I sent something funny to it. Now let's just send it the high value again. We'll give it, say, that was set to 30, so we'll make this 32.00. Oh, not there. Set high, and we'll set this to 32.12. And we'll publish that. And we'll see this one should go to 32 with the extra 2 digits. There it is. So now if I heat this up, when it gets to 32.12, it should turn the fan on. There we go. Almost. There, now it's on. Let it cool down. As soon as it gets below 30, it should turn off again. So both of these would now be responding to the new values. There, and it's back off. And if I look at the fan state that's been in here, I don't know if it was there long enough to, there it was on, and then it was back off again. So you can see that's the whole thing all nicely working. So we're using MQTT Lens to monitor the fact that it is being sent out properly to the cloud, and it is, which is excellent. The display has now been nicely improved. We now have the CC3200 responding to published data that could come from a smart device, it could come from a tablet, a desktop, it could come from another automated system. It doesn't really matter. The system doesn't care. We've got, and I'll put a little diagram up here now to just show you how this connection is with the MQTT server, just a straw model. But there's a complete disconnect between the publishers and the subscribers. And either end can be both a publisher and a subscriber. And as I said, when we do this next video in a couple of days, I will show you how to use Node-RED, which is an application that runs under Linux and many other things, to subscribe to the data and give us a nice little UI display that you can use on a smart device. For now, though, this completes this video. We now are officially an Internet of Things device. We are now officially publishing to the cloud. So that's excellent. That's all well and good, and we are now done. So tomorrow, I think the schedule that might have been published by Texas Instruments said that we were going to add local buttons and things, but my intention there was to add the Node-RED with smart device buttons and things so that you can actually have your phone when you're wandering around the house and you just hit a button and it can turn the fan on and off, or you can change the set points using a slider and things. So that's what we're going to do tomorrow, and then on Saturday we are going to look at making this model completely work with a battery and a solar panel so that you could put this outside or somewhere where you don't have easy access to power, and it will still, because it's connecting through Wi-Fi, still be able to work quite happily and submit the data and be controlled by it. So you could use this in a greenhouse, in a garage, or whatever you wanted to if you really needed to do that. And you can still be able to remotely monitor it, etc., etc. So that's it for now. I hope you're enjoying it so far. I think everything seems to be going reasonably well. The one thing I will say again, though, is that remember, I don't have the amount of error handling in here that would be required to make this a very, very robust product. If you were allowing other people to publish data, they could publish some non-valid characters for this high and low settings, which could disrupt things a little bit. If you're writing the whole application, then that shouldn't really be an issue, but just be aware of that. This, as a final production project, you would need to just add that extra error handling. Anyway, we're done, so I will see you tomorrow.